Welcome to IIMT Group of Colleges. Myself, Pankaj Tiwari, Assistant Professor, IIMT College of Pharmacy, Greater Noida. My topic is normal distribution. Normal distribution is part of statistics. Normal distribution is learning in probability theory. Normal distribution is the most important part of students for pharmacy department, engineering, and UG and PG other traditional courses. Now, first we will solve to show that uh, number distribution content. Introduction, definition, properties of normal distribution, and normal probability curve, application of uses of normal distribution, importance, and problem solved. Introduction. Normal probability distribution, or commonly called the normal distribution, is one of the most important continuous theoretical distribution in statistics. Most of the data relating to the economics and business statistics, or even the social and physical sciences, conform to distribution. The normal distribution was the first discovered by English mathematician De Moivre in 1666. 67 to 1764 in 1733, who obtained the mathematical equation for the distribution while dealing with the problem arise in the game of chance. Normal distribution is known as the Gaussian distribution. After the Carl Friedrich Gauss, 1777 to 1885, who the used the distribution to describe the theory of the accidental error of the measurement involving in the calculations of the orbit and the heavenly bodies. Today, the normal probability model, the one of the most important probability models in the statistical analysis. Definition. If X is the continuous random variable following the normal probability distribution with the mean mu in the standard deviation sigma, then the probability density function in PDF is given Px is equal to 1 upon square root of 2 pi sigma e power minus 1 upon 2 x minus mu upon sigma e power a whole square. X is belongs to minus infinity to infinity. The standard normal probability curve is given by the equations Pz equal to 1 upon 2 square root 2 square root of 2 pi is sigma e to power minus 1 upon 2 z square. Z is less minus infinity to plus infinity, where x is the value of the continuous variable varies to x is belongs to minus infinity to plus infinity, means the mean value sigma is the standard deviation, e is equal to 2.7183 and square root of 2 pi is 2.5066, that equal to x minus mu upon sigma. Properties. Properties of normal distribution. It has the following properties. The graph of Px is a famous bell-shaped curve shown in the figure. The top of the bell is directly above the mean mu. The curve is symmetric about the line x equal to mu, z equal to 0. That is, it has the same shape on either side of line of x equal to mu. Or z equal to 0 because the equations of the curve Pz is remaining unchanged if change is z to minus z. Since the distribution symmetrically mean, median, and mode coincide, thus the mean equal to median equal to mode equal to mu. Since mean equal to median equal to mu, the ordinate of x is the mu and z equal to 0. Divide the whole area into the two equal parts. Further, Since total area of under the normal probability curve is 1, the area to be right of the ordinate as well as the left of the ordinate equal to mu if the z equal to 0 is the 0.5. Since the mean and equal to median equal to mu with the ordinate x equal to mu, z equal to 0, divide the whole area into the two equal parts so that the since total area of under the normal probability curve is 1. The area is the right of ordinate as well as to the left ordinate is the x equal to mu or z equal to 0 is 0.5. Median Q3 Q, Q3 minus median is equal to median equal to Q minus Q1. It belongs to Q3 plus Q1 is equal to 2 median mu. Q3 and Q1 is also known as quartile deviation. Uh, Quartile deviation, the partition value of in statistics. Next, normal probability curve. Since the distribution is uh, symmetrically, then the px is in x is equal to mu. Since the distribution symmetrically, the moment of curve is schemeness is given by beta is equal to 0, sigma equal to 3 up to 0. No portion of the curve lies below the x-axis since px equal to being the probability can be never be negative. Theoretically, the range of distribution from minus x is minus infinity to plus infinity, but partially its range is equal to 6 sigma. Distribution is unmodal. The only the mode of occurring is x equal to mu. X-axis is a asymptotic to the curve in the uh, numerically large value of x is no on the either side of the line of x equal to mu. The curve is become the parallel to x-axis and supposed to the meet of it at infinity. Mean deviation MD is about the mean and median and mode M is equal to MD equal to M naught is given the mean deviation equal to square root of 2 upon 5 in 4 pi upon 4 upon 5 4 upon 5 sigma. Quartile deviation QD is given by QD is equal to Q3 minus Q1 upon 2 0.6745 sigma is equal to 2 upon 3 sigma. Also, the QD is equal to 2.2 sigma is equal to 4.5 sigma is equal to 5.6 into 0.5 sigma is equal to 5.6 mean deviation belongs to quartile deviation equal to 5.6 median. Approximately, quartile deviation ratio of mean deviation ratio of standard deviation is equal to 2 upon 3 sigma ratio and 4 upon 5 sigma and sigma is equal to 2 upon 3 ratio on 4 upon 5 is equal to also is a ratio of 1. Total deviation, mean deviation, standard deviation is equal to 10 ratio 12 ratio 13. Distribution area of the normal curve is for A, mu plus minus 1 sigma cover the 68.27% area. B, mu plus minus 2 sigma cover the 95.445% area. C, mu plus minus 3 sigma cover is 99.73% area. This is the curve of under the area of under the normal probability curve. In the middle part of the 68.26% area, 90 and outside of the this over the 95.44% area. And last is over the cover is 99.73% area. And middle part of this region of is sigma x equal to mu equal to z equal to 0 minus 1 से plus 1 minus 1 से mu minus sigma and plus 1 is mu plus sigma then minus 1 से minus 1 to 1 minus 2 से 2 so minus 2 is a mu minus 2 sigma and plus 2 mu plus 2 sigma minus 3 to 3 minus 3 is known as mu minus 3 sigma positive part of 3 is mu plus 3 sigma. Application. Application or uses of normal distribution. The normal distribution can be used as approximately the binomial and Poisson distribution. It is the extensive using the sampling theory of the help of the estimate parameter from the statics in the find the confidence in the limit of parameter. It has a wide use of testing of statistical hypothesis or test of significance, in which the always assume that the population from which the sample has been the drawn should be normal distribution. It has significant application in the statistical quality control as control chart in this statistical control quality control the closely related to normal distribution. It can be used for smoothing in the graduating and distribution which is not the normal in simply in the contract and the normal case. It serves in the guiding guiding the instrument in the analysis and the interpretation of the statistical data. Importance of the normal distribution. Normal distribution is the occupy is a very important role of statistical. We have the invalid below some of the important application. If the x is the normal value, the mean mu is the variance is sigma square. We have the proof that the p is mu minus 3 sigma is less than x is less than mu plus 3 sigma is equal to p over the bracket minus 3 is less than z less than 3 is equal to 0.9973. P is over the bracket in z z in mode of z is greater than is 3 is equal to 1.1 minus 0.9973 is equal to 0.0027. Thus the property standard normal variate out going to outside the limit of plus minus 3 is the practical zero. In other words, in all the probability we should expect the standard normal variate lie between the limit of plus minus 2 plus minus 3. This is the property of the normal distribution from the basis of the entire the large sample theory. Most of the discrete distribution, binomial distribution, Poisson distribution will tend to the normal distribution and its number of trials increasing for the large value of the and the completion of the probability for the discrete distribution become quite the tendency and time the consuming in in such cases in normal approximation can be used with the great great case and convenience. Third is almost the extract the sampling distribution that is student test in distribution in standard F distribution, fission in Z distribution, chi-square distribution confirm the normal distribution for the large degree of the freedom of and to infinity. The whole theory accepts the simple sample the testing in the t-test and then chi-square test based on the fundamental assumption that the parent population from the which is the sample have been drawn following the normal distribution. Perhaps one of the most important application normal distribution and one of the most fundamental theorem in theory of statics, the uh, center of limit theorem, which may the starting the follow is x1, x2 is xn are the n independent random variable following any distribution, then the under certain with very general condition is sum of summation x is equal to x1 plus x2 plus x in the arithmetical normal distribution, that is f function x is the following normal distribution and belongs to infinity is the immediate consequence of the theorem of following result if the x1 x2 send the sample random sample size from the population mean mu in the variance square sigma square the sample of x bar is equal to 1 upon n is x1 plus x2 is xn 1 upon n summation x is the arithmetically normal if n belongs to infinity the mean mu and sigma square upon n. 6 is a normal distribution use the statistical quality control industry from the setting the control limit of from the construct control chart. Uh, and W. Jan Jordan International Bureau Standard describe the importance of the normal distribution article in the following words. This is the graph of bell shape in normal distributor from in the standard describe the importance of normal distribution. Depend that the above representation slightly enough in the giving the shape of the normal probability curve depend in the reveal the population involving normal distribution in the following question. Everybody believes the law of error, the experiments, because they think it is the mathematical theorem and mathematician because think in the mathematical facts. Example, assume the mean height of soldier to be 68.22 inches with the variance of 10.8 inches. How many soldier regiments of the 1,000 would you accept to be uh, first over 6 feet tall and below 5.5 feet? Assume the height of normal distributed. So confirm solve this question. Let the variable x is denoted by the height of in inches in the soldier. Then with the given mean is equal to mu and 68.22 and the variance is sigma square to 10.8. A soldier will be over the 6 feet tall and x is the greater than 12 into 6 in 72 inches in the height of. When x equal to 72, z equal to x minus mu upon sigma is equal to 72.72 minus 68.22 square root of 10.8 is equal to 3.78 upon 3.286 is equal to 1.15. The probability that the soldier is over 6 feet is equal to 72 tall in 72 foot tall in the is the given by p is equal to x is greater than 72 is equal to z equal to greater than 1.15. The value of 1.15 is equal to 0.3749. Then it's equal to 0.5 minus 0.375 3749 equal to 0.12. Final is normal from the normal table. Hence, the regiment of 1,000 soldier number of soldiers over the 6 feet is tall is 1,000 into 0.1251 equal to 1 to 125.1 is approximately 125 is soldier over the 6 feet tall. Second, the probability that the soldier is below the 5.5 is equal to 66 given by x less than 66. 66. And p is that is less than 66 minus 8.2 22 upon square root of 10.8 equal to p z is less than minus 2.22 upon 3.286 equal to p is z is less than minus 0.6756 is p z is greater than 0.675 by the symmetry 0.5 p 0 is less than z is z is less than 0.6756 equal to 0.2501 normal table, also normal table, is equal to 0.2499 approximately. Hence, the number of soldiers is 5.5 feet in the regiment of the 1,000 soldiers. 1,000 into 0.2499 is equal to 249.9 approximately 250 soldiers in below the soldier of 5.5 feet. It's a normal table graph, it's normal distribution graph over the value of. Thank you. I hope you understand the normal distribution topic.